Good afternoon, everyone. Thank you so much for joining us. My name is Desmond Martin. I'm the program coordinator at NextWaveSTEM, and today we are in another one of our free professional development webinar series, How to Teach 3D Printing Remotely. Thanks. We are really excited because the school year is under full swing. A lot of us have engaged students in our classroom in the last few weeks or even just starting this week. And we're, for one, really energized because we've got to see their faces if we haven't seen them during the course of the summer. But for another thing, we got the chance to really be innovative and try some new things with our students. When you think about hands-on and innovative learning, 3D printing is an amazing platform because when we think about 3D printing, oftentimes we think about the actual machine. And the machine itself can be sometimes really intimidating. If we're new to 3D printing, if we have limited experience or even no experience with 3D printing, it seems like something that's really daunting and something that can do more harm than good when it comes to our personal mental health. But let me tell you, it's much more than that. In 3D printing, we have this technology that just isn't spitting something off of a printer, but also involves these really complex ideas in computer-aided design and process and management. I am a mechanical engineer by training, and I cannot think of a technology, an emerging technology, better suited to teaching students different aspects of the engineering design process. So I'm really excited to talk about how we can engage our students with 3D printing remotely, even if they are working and may not have an access to a physical printer. Before we get started, there are a few housekeeping items we want to keep in mind. The first is that for our Illinois educators, we're really glad to have you with us today. Today's professional development session is worth one professional development hour with ISB, Illinois State Board of Education. You will be receiving the certificate for your PD hour in a follow-up email later on today. Now, for our educators who are not from Illinois, NextWaveSTEM, we're based here in Chicago. But for those of us who are a little more further afield, we do not currently have partnerships with professional development organizations, state boards of education outside of Illinois. However, if you just want their certificate to prove that you were with us today, no worries, you will also be receiving that same professional development credit hour. In addition to the PD hour, everyone will be receiving a recording of today's webinar and a copy of the slide deck. Hopefully those things can be some resources for you as you work with 3D printing with your students. Another bit of housekeeping is that we are in webinar mode today. That means for as much as we would love to hear you and see your lovely smiling faces, we won't be able to. However, you still have the ability to give us some input. The chat is open. Some of us have already jumped in and started dropping in where they're from and what they teach. We appreciate you so much. If you've got any questions, if you've got any comments, if you have any interjections or just funny stories, I love all that stuff. The chat is completely open for you to use today. The Q&A function is also open. So if you've got a question that you want to leave anonymous and just want answers to on air, either way, we'll be able to get your questions answered via those media. With that all being said, we will go ahead and jump right into it. For those of you who have been with us in previous professional development sessions before, welcome back. This is the part that you know pretty well, and that is starting at the beginning, talking about NextWaveSTEM, who we are, and what we believe. At the beginning and end of the day, NextWaveSTEM is a company that believes in our students. It believes in our students and their ability to be innovative. It believes that our students are going to be the future innovators that we need to solve some pressing problems. Climate change is real and it's here. There is a global pandemic that's changed all of our lives. I'm sure all of us have taken notice of that. There are other or I should say equally pressing issues that we have to deal with. Things like potable water, being able to ensure that all of our citizens can access their rights when it comes to participating in the democratic process. Being able to feed and provide food for 7 billion, rapidly approaching 8 billion human beings living here on the earth. NextWaveSTEM believes that a lot of those solutions are going to be technical solutions, and that we need students to have a robust STEM background, a robust STEM education in order to continue to matriculate into secondary and tertiary STEM programs. We need more engineers, mathematicians, scientists, artists, technologists to come together and solve these problems. But we know that our students cannot do that without you as educators. You are the linchpin, you are the most important part of this process. Without teachers to teach STEM, our students won't learn STEM. So Next Wave STEM, we started off as an out of school time program, really serving students here in our Chicagoland area, and we've grown. Next Wave STEM now offers K through 12 curricula in emerging technologies like artificial intelligence, robotics, drones, 3D printing, which we'll be talking about today, and even I think I mentioned everything. Yeah, those are all of our technologies. We have a few things that are in the pipeline. We license those curricula. We will do training so that you know how to execute that curricula in your classroom, and we provide all of the equipment that you need. Try to be a one-stop shop and a one-stop option for you as educators. We are here to serve you and make sure that our students can reach towards a future that benefits us all. So in today's webinar, we have two primary goals. Our first is that we want to learn how to use the Tinkercad cloud application to teach skills in computer-aided design and 3D printing. Something that I mentioned a little bit earlier is that 3D printing just isn't the printing part. There is a design component where we have to understand how to manipulate 3D objects and get them ready for our printer. And then there's this idea of slicing, actually translating the raw 3D image that we may be able to produce with our students into something that our actual 3D printer can understand and print. Both of those things are things that we can teach our students how to do remotely. But secondly, after we talk about how to run Tinkercad and make that an effective remote experience for our students, we want to think about a remote learning instructional model. What does this look like? How can students take what they might be doing, learning 3D design and learning what I colloquially call slicing? How can they take these skills and integrate them into a model that works remotely or even hybrid? We'll talk about how to do those two things. I'm super excited. I do want to add this one last caveat before I move on. I'm not just excited, I'm excitable. And when I get excited because I'm excitable, sometimes I can speak a little bit quickly. If you need me to slow down or you just want some clarification or have any questions, jump right in there on that chat and we will address them. And also want to give a shout out to Jennifer and Mary. Hey, thanks so much for joining us. Hey there, Mary. Thanks. Good to see you and have you with us again. So let's start at the beginning. How do we get in the flow with Tinkercad? Where do we start? How do we get our students set up? And how can we actually use this for what we say we want to use it for, which is 3D printing? Well, the first thing to do is kind of to get an understanding of what Tinkercad is and getting our class prepped. With a lot of our instructional technology, half the battle is the actual logistics. How do I get my students logged in? How do I get them registered? And how do I make sure that they're not just doing their own thing on a personal account? It's something that's connected to our school. It's something that's connected to our LMS. If our school is a Google Classroom school, how is it connected to the Google Classroom? Well, fortunately for us, all of those things are really super simple to do inside of Tinkercad. So what I'm actually going to do is transition my screen share over into Tinkercad so we can see exactly what that looks like. So currently I've already kind of cooking show style jumped into Tinkercad a little bit ahead of time so that I can show you what this looks like on the back end for an educator. inside of Tinkercad, and this is a little bit collapsed, we have this hamburger menu. I call it a hamburger because it's got these 3 layers here. Clicking on that menu, you have a few different options that you can check on and that allow you to manage your actual classroom load. When I click on classes, it's going to navigate me from the screen, or it should. There we go. Clicking on classes, I have the ability to actually create classes with students. For example, I have already a couple of classes set up, something I was playing around with a few of our other employees here at NextWaveSTEM, but I've got this webinar example already. Clicking on a class, we actually have the ability to drag and drop in names. So if you've got your roster, it can be something as simple as on a website or much more likely an Excel spreadsheet. You can click to add students and we can copy and paste all at one time, all of those students, or I can type in the names of students as we go. So just that simply, our students are connected. Now, I just got a message saying that we can't see anything that's going on. Thank you so much. My screen share seems to have paused. Okay, I think we're back up and good being able to see what's going on. Yeah, at least I think so. If we can't see the screen where we see add students, just let me know. Oh, awesome. Okay. Jennifer, really good question. Can they be rostered through Clever? Great question. I will have to check on that, Jennifer, and get back to you on that one. I'm not sure if they can be inserted through Clever, but I'm pretty sure that if you've got a copy and paste function on an application, you can even go as far as creating a list of students. For example, I'll use my siblings' names. And you'll get a bulk import as well as these nicknames. One other thing to think about as we are using Tinkercad is the ability to create a class code. Let's say that you're using Tinkercad out of school time. You might not have a fixed roster, or you may be working in an organization or a public library. You can generate a class code, really simple. You can email this, copy and paste this, project this in your classroom, post this to a Google Classroom chat board, for example, and your students can join in with their own personal accounts, and everything gets nested underneath you as the instructor. All of this also seamlessly connects to Google Classroom. So this makes your life super easy if you're a Google Classroom school, and pretty easy if you're not a Google Classroom school. All you have to do is set up your own Tinkercad account, and anybody who logs in using your class code is automatically entered into your class. When they're entered into your class, you not only see your rosters, but you see any designs that your students have created using Tinkercad logged in underneath your class code. So you have complete control. You can edit, delete, comment on things. You've got full control using the Tinkercad login. So now that we have got this idea of being able to interact with our students and get them set up in the class, the next logistical thing that we want to think about is building our own skills. It can seem like a difficult thing to learn how to do 3D design, but in actuality, it is fairly simple. And it's made even simpler because Tinkercad provides us with resources. So when we are learning to do 3D printing, 3D design, it's a 3-step process: design, slicing, and printing. And before we do anything, we can open up an entire world of possibilities working with our students through functional design. What do we mean by functional design? The things that we're shared within Tinkercad lessons instructables courses, and our NextWaveSTEM materials as well. Any of these resources can teach you how to use some of the basic functionalities of Tinkercad to do some really, really simple design. And it's designed that's specifically made for 3D printing. So I can already hear you saying from hundreds or dozens of miles away, okay, Desmond, that sounds all great and good. You're telling me that I can do 3D design really simply, but is it actually simple? The answer is yes. It's so simple that I will actually show you a quick demonstration of 3D design using Tinkercad. So we're going to change my screen share one more time. And what we have is my actual Tinkercad home screen. The screen allows me to see different types of designs, any projects that I set up, a little social media from Tinkercad so that you get updates. And there's also a design library, so things I've already created. So I'm actually going to click on create a new design. While that's loading up, we got a really good question here from Jennifer. What grade level would you recommend the Tinkercad tutorial for? Great question. Tinkercad honestly can be used as early as about 3rd grade. We love Tinkercad as a place to begin. It's a part of the Autodesk suite of services of design software. That means that things like Inventables will take our students into more complex software, Fusion 360, AutoCAD and SolidWorks, things that professional engineers and designers, architects will use to make their software. Tinkercad is a natural starting point and a natural step up into those other software. So we see Tinkercad used from students from 3rd all the way through 12th grade because it's a really useful introductory software. But you can naturally progress into more robust software from there. So this design space is loaded up. I'm actually going to close the sidebar, hiding our shapes, so that we can get a better sense of this space. Navigating around the space is really easy. There's a view cube that lets us know our orientation so that we don't get lost. And by dragging and dropping the cube, I can navigate around the space. I can also click on specific portions of the cube and get different angles that way. And if I ever get really, really lost, I can hit this home button and it takes me back to the view that I started with. Now, I love Tinkercad because Tinkercad is simple. It's about adding and subtracting. And you're adding and subtracting 3D shapes. This is a little bit different than standard computer-aided design software, computer-aided drafting software, because in the design world, if you want to make something 3D, you started off with a 2D drawing, something that you would draw on a sketch paper, and then you would add perspective. You're basically playing some camera tricks, and then eventually you'll be able to visualize and see what the object will look like in 3 dimensions. In Tinkercad, instead of drawing 2-dimensional objects, we start with 3-dimensional objects that we can drag and drop. I'm going to hide that menu for now. And when we drag and drop these objects, we can then manipulate their dimensions. So instead of drawing lines and cutting things, I'm actually going to very finely adjust the shape. So let's say that I want a length instead of 20, I want, oh, not 1,000, but we'll do 5 times the distance. So all this is measured in millimeters. These units can be changed. I'm going to drag and drop and recenter. I'm going to also zoom in on my shape. And I'm going to continue to resize. So on the edge, I like 20 for the height. That's a little bit less than an inch, but I think that's a little bit too tall, so I squash that down. So this is simple manipulations of the dimensions of our 3D shape. And I can do things like rotate the shape in all 3 dimensions, so I can get things looking the way that I want them to look. Some of us are much more familiar with this, or we may have some 3-dimensional design skills ourselves. I'm going to adjust our view cube. And I can do this with any shape that I add to Tinkercad. So if it's sphere, I'll actually delete that because the transformations may be a little bit harder to see. But if I take a cylinder, I can either type in specific dimensions, I can get very fine, or I can just drag and drop the dimensions that I want in order to get the shape I want. For now, I'm going to let this cylinder hang out right over here because we're going to end up using him later. So in Tinkercad, you're able to manipulate your shapes, all kinds of shapes, basic shapes, stars, hearts, but more complex shapes as well. You can do things like text and numbers. So in this case, I'll actually grab a text block and I'm going to lay it in over here. I'm going to adjust this text. I think I'm going to be a little vain and just spell my own name. So I've got a text block here that I can drop in. And then I can do other things for other applications. Say I want to design something that is really recreational or represents some kind of character. I'm building a diorama or I'm sketching out 3D character design for a movie. Maybe I jump into characters, things like hand components, different things. If you've ever used a potato head, Mr. Potato Head before, that we can use to do some 3D animation. Maybe answering the question of what came first, the chicken or the egg. So I'll grab an egg. And of course I can manipulate those shapes as well. We'll delete that egg for now. So I might play around with different characters for animations purposes. But I can also do things like physical connectors. The great thing about 3D printing is that what we print doesn't have to just be static. If I print something like a socket, get the socket to cooperate. I'm going to zoom in on my socket. If I print something like a socket in a ball joint, well, now I've got something, two pieces that will actually snap into each other. And connecting those with other physical pieces now allows me to build something that can move. I'm going to select both of these and delete. I'm going kind of quickly because I know we've got a decent amount to cover. In addition to these engineering shapes, I'm going to put home so we can see everything that's going on. I can also do special shape generators. Things like boxes and screws and bent pipes and springs for engineering purposes. I can also do actual circuit assemblies. If I'm building things with Raspberry Pis and basic computing, I can do even components like Arduinos and servo motors and AAA batteries, things that we can actually that we can actually design ahead of time if we're working in a circuitry class can be imported into Tinkercad for effective design. Question here from Christine is a really good question. Are jointed pieces printed as single unit? If not, how are you assured that they will fit? Really great question, Christine. We have two ways that we can go about that. We can do an alignment. So I'll actually jump back into our connectors. I'm going to grab the seated ball. And I'm going to grab the socket. And I'm just going to rotate the socket 180 degrees. This is a really good case study. And we're going to zoom in on those. Okay, so what you'll find with our sockets in Tinkercad is that the scaling is locked. I am unable to adjust the actual dimensions of the socket here in Tinkercad. What will happen in the way that I can adjust the size of how these parts work is when I get into the slicer, I can scale everything up and scale everything down. That's something that we'll be able to talk about in just a few minutes. But these socketed, these jointed portions are locked in. They're designed to fit in with each other. So the best idea is to take these parts and print them separately. Make sure that there's some amount of space in between them so they print, we can remove the supports and they'll snap right into each other. If we're feeling really particularly adventurous, then I can use an alignment tool, align them right up on the center line there. And after I've aligned them, I can arrow over this joint right into the socket. You, in theory, could print this object this way. There is a small gap that the printer may leave depending on your printer settings. So you can print your ball and your socket right together, and with a little bit of force that can move. We've definitely seen 3D printed objects come out with that idea in mind. Is it what I recommend? No, because you have to be extremely precise when we print an object like that, where the tolerances are so small. But that is a way that you can go about that. Really, really great question. I love that question. So we'll delete our little example right there for now. Different kind of objects that we can print. We were talking about assemblies and components, but we also have the ability to interact with some other objects that are kind of outside of the normal realm for what we might use in 3D printers for. The Smithsonian has actually done highly detailed three-dimensional scans of some of their artifacts and has included it inside of Tinkercad. So for some of us who are big fans of Abraham Lincoln, I'm in Illinois here, so we're in the land of Lincoln. You might want to introduce your students to how Lincoln may have looked in the real world. Smithsonian has actually done a life mass of Lincoln, scanned it and uploaded it. That may be your particular cup of tea in your social studies class. It's not mine, but there are all kinds of things we can explore. So what we have are these shapes that we can manipulate, some that we can't because they snap together in really particular ways. Yes, I agree, the life mass is a little bit creepy as well, Christine. And the big idea inside of Tinkercad, I'll get rid of these shapes so we can see a little bit better. The big idea inside of Tinkercad is the ability to add and subtract different shapes. So we'll zoom in here. I've got these letters that are interlaid over this initial plate that I initially drew. I'm actually going to just resize these letters freehand over into my plate. I can actually rotate up and see a little bit how I'm doing up there. So I can resize down here a little bit. Now, right now, I've got actually two shapes. I've got one flat bar. I've got the letters of my name. And if I highlight them both, just like you might highlighting on a web page, I've got two shapes here. I can click this button to group them. And two simple shapes just became one very much more complex shape that I'm now able to resize and manipulate. Got a really good question here about the screen size. Yes, let's adjust the screen size here. I just got a note that it's kind of hard to see what's going on. Let's give that a try. So I'm going to adjust my screen. Let me know if this helps at all. Okay. Okay, you might have seen just a little bit of a change on your screen with regards to the screen size, the proportions. If it looks a little bit crazy, just let me know. I can certainly make that adjustment as necessary. So what we've seen so far is me manipulating two solid shapes. These two solid shapes are what become a little bit of the way, well, not a little bit, but the main way in which we build shapes. But just like we can add shapes together, we can also subtract shapes. That's where, my friend, the cylinder comes in. I can take the cylinder and manipulate it over here. We're going to zoom in on him so we can get a little better idea of what's going on. I'm also going to adjust the height of my cylinder down a little bit, and we're going to get a top-down view. I can take the cylinder and resize it however I would like to resize it. It doesn't have to be perfect for this application, because what I'm going to do after I get my cylinder the size I want, is I'm actually going to transform the cylinder into a negative shape. I'm going to change it into a hole. Yes, you got it exactly right, Doreen, like a keychain. So I can take this empty form, I can combine it, select everything, the empty shape and the solid shape. And if I group again, what I've done is I've cut out a piece from my solid shape. That's how our students design in Tinkercad. They take solid shapes and empty shapes, kind of those hollow shapes, and they add and they subtract them from each other to get what they want. Yes, the keychain is a great starting project for students. I've seen Jen in the chat talking about how sometimes students will try to make name tags and they end up floating. They have to manipulate different pieces. That's difficult to do. And that comes with practice from you as an educator. It's learning our different tools. For example, as I zoom in here, we can see there's a little bit of this cone-shaped arrow. Grabbing that allows us to float and drop our piece. Knowing how to rotate our piece the different ways that we want it to rotate. We'll let that one get reset back to where it was. And clicking around our view cube, those become really important skills for us and for our students so that we can see our alignments. But the align tool, it becomes really critical as well. I'm actually going to select all of my shapes and I'm going to ungroup them. So now we got individual shapes here. It's really easy to have your shapes that are broken apart, their own particular shapes, and they're not lined up. Shapes might be floating on different areas and different levels, and we want to put them together to make them work. Our align tool, I'm going to highlight these two shapes, my name and the nameplate. Our align tool up here, L, allows us to preview getting things on the same level and then getting things lined up, and I'll even change the view, getting things lined up in the same center point, and they just snap together. Learning these different tools allows us to actually design what we would like to see in Tinkercad. So that is kind of the high level idea of what we can do, but those are skills that we grow into. The NextWaveSTEM materials, as well as the other materials I shared from Tinkercad and Instructables, are really great ways for you to practice and grow into those design skills. Going to press on because we've only got so much time left and got a little bit more to cover. So I'm going to make an adjustment on my screen, and we're going to adjust our screen share as well. We've got some really good questions and comments coming in. And in fact, we just got another question. Okay, awesome. So we want to build our skills. And as we're building our skills, we're also getting these abilities to design. One thing that I didn't show you just for lack of time was this idea of being able to mock up whatever we design in Lego and in Minecraft bricks, using different shapes like the Oregon Museum of Science and Industry design space to do things like architectural and interior design becomes really powerful. And those fully printable objects, like things we see from the Smithsonian, or fully printable dinosaurs and skeletons that use some of those ball and socket joints to be able to snap together and be manipulable. Those become ways for our students to get really engaged with 3D printing immediately. So covered a whole lot there. The bigger question might become, okay, what does this mean for distance learning? How can I effectively do this with students? Let's assume that I really get good at the design of 3D printing? Let's say that I get good enough that I can teach it. How will I actually engage my students over time? Got a really good comment here, actually, from Christine. I think I need a life-size skeleton. If you've got a big enough printer or enough skill and a lot of patience, you can do that with almost any 3D printer, but that could be a conversation we can have a little bit offline, Christine. The question might now become, how do we do this with the students remotely? And this goes back to our actual design model at NextWaveSTEM that we find works both well remotely and in traditional in-person instruction for students. It's the 5 E's. We want to engage our students, explore the subject matter with them, explain a little bit more of what's going on as they are working through the technology, give them the ability then to take hold of that work and elaborate, build on top of what they've learned and what they're designing, especially when we think about the engineering context in which 3D printing fits so well. And then after we've done all that, it's back to us as the instructors, and sometimes working collaboratively with our students to evaluate the work that's being done. It just doesn't have to be complete instructor evaluation, but also peer evaluation. What does this look like in practice? Well, we can imagine a classroom session. A lot of us are in between two worlds. We may be completely remote right now, where our students are having some self-guided learning, having some virtualized instruction. We may be in a hybrid model. That may be the other world that we're in, where we have some students who are separating the populations. Let's say you've got student group A and student group B. They may be taking time switching in between when they're in the school. There may be some time of virtualized instruction where they're with you for a day or two online on the computers doing Zooms or Google Hangouts. And there may be some remote work that they're doing as well. And then some of us are right back into it using our socially distanced teaching models in school. We're in a situation when we're thinking about remote instruction where we begin the class with whole group direct instruction, thinking of those live instructional days. You're engaging with a real world problem to solve. We're really thinking about 3D printing as a way to build our students' engineering prowess, to think about real world solutions and real world applications. This is introducing the actual problem. From there, we collaborate as a whole group. And I kind of put whole group in quotations because breakout rooms, separating into small groups, works really well for this as well. We're able to discuss the problem, to really whittle things down, think about our constraints, think about how big the solution may need to be or who the solution is for, getting into the nitty-gritty. From there, we're in small group collaboration. Our groups may be in chat rooms or they may be face-to-face in our breakout, where we're starting to do the more in-depth design work, sketching, pulling in ideas into Tinkercad of things that we think might work, sharing screenshots or even sharing our screens in our small group moderations of that individual work becomes really important. More and more of the actual design work is taking place. More and more of the iteration, more and more of the ideation, even before we get into the design, is taking place in our small group. From there, we might circle back around to our whole group instruction because there may be some skill building that will help our students. When we think about using the align tools, we're gonna think about adding and subtracting shapes. We're gonna think about small modifications to our designs in terms of dimensions, or even in terms of more specific settings with our design that we didn't think about. Your expertise becomes a student's expertise, and they can even follow along in some of that instruction and some of the design work that you're doing and sharing on your screen. From there, there's been so much sharing back and forth, so much work that's been happening collaboratively between you and the students, or from student to student. There's a chance for you to step back a little bit. So this is the individual design work. Now that they have gained some skill mastery or just built some skills, they're able to do some of that design work on their own. 3D printing becomes really useful because design work that they do on their own, work that's done on their model, that model can be shared with other students and then iterated on. You can actually click and create a link. And while two students can't work on the same model at the same time, you can kind of switch off and work on models collaboratively that way. And then when that work is done, once it's submitted, you're evaluating. That's where you're adding your feedback. That's where you're able to participate in really getting students the kind of input that gets them closer to a design solution. And that can really get carried out through your LMS or even through Google Classroom. So if you're a Schoology, if you're a Moodle, if you're Google Classroom, you can submit all your designs through there, either through screenshots, or you can actually upload the 3D object really simply into Google Classroom, for example, and then share that. You can even email these files very simply. They're much smaller than the limit. So as an example of what this real world instructional model looks like, we would start with proposing this question to our students. What's a real world problem for our students to engage with? And haven't asked for a lot of feedback so far, but this is our first moment to be able to do that. So I want to open it up to our participants. Take maybe a minute and think about what is a real world problem that you might want your students to consider that might be solved using the 3D printer. The chat is open. I'm actually going to be silent for a little bit as those minds are working, those fingers are furiously typing. What is a real world problem that your students can engage with? Doreen, that's a good one. Building rain gauges. Yes, if you don't have one and you want to teach your students about design and maybe designing a specific customized rain gauge for your situation. Really good example. Christine, yes, creating no-touch assistive devices. That is a great example. Are there any other real-world examples that you can think of? Yep, Mary's just with it. PPE, personal protective equipment. There's still a really important need for that equipment for our frontline responders. Oh, yeah, hooks for their tablet chargers. Just being more organized. One of the best applications that I saw for a 3D printer was a student in one of our Chicago classrooms who has a computer lab. And the computer lab has the computers and has the headphones so students can engage with their media and not disturb their other students. And you've got headphones and you've got headphones and cords and cables all over the place. A very simple headphone holder that attaches to the side of that computer changed the whole look and feel and organization of the lab. Those are some really good examples. Thank you so much for sharing. Missing Legos cookie cutters. Yes, Jennifer, that's so cool. Yes, you can print Lego shapes. It's a little bit difficult because Lego shapes are really fine. And some of our 3D printers won't produce great Lego shapes, but you can absolutely produce Lego shapes using the material that Lego uses, ABS, really hard plastic. So when we think about engaging real world problems, what our students are doing is that they're practicing citizen engineering. We've seen 3D printers used to print and manufacture custom lead filtration devices for homes and buildings that still have lead service lines. It's not just Flint, Michigan, but cities all over the country that have this problem where we're seeing injuries happening to students. Mary mentioned PPE, personal protective equipment, things like face shields, masks, and respirators. Someone in our chat, I'm going to scroll up a little bit because it was really good. Yes, Christine mentioned assistive touch devices, things that make sure that we can interact with the world around us while limiting our ability to get sick because of physical transmission. That becomes a really powerful use for a 3D printer. We had a couple of other ones come in as we were speaking. So many good ideas. Small boxes to store individual supplies over the air. Yes, I love it because those boxes can be really customizable. So we can get a box that fits their favorite ruler and protractor perfectly, or their laptop perfectly. And how to design a top for markers that are always lost. Yes, we can do replacement parts. That's a big application for 3D printers. Many a hobbyist has had their washing machine breakdown or their refrigerator breakdown. And if they can figure out the part that's missing and they don't want to go to the Sears catalog and order something for $30, they can spend a couple of cents and a little bit of time and print that part to fix their washing machine. I don't recommend that if you're new to 3D printing, but if you have some time and don't mind frustration, that might be a good project for you. 3D printing allows our students to make things that are usable by real people solving real problems. And I just want to highlight, if you look at our example of our face mask here, a face mask is a really, really great way to get started with 3D printing, because the portion that's 3D printed is only the top part that's orange and the bottom clip that's orange. It is an extremely simple design. This face shield can be made by some other kind of plastic. I've even seen people get creative and actually cut 2-liter bottles, the plastic from 2-liter bottles, and be able to wrap those around for the face shields. And that's an effective face shield with some elastic that you might get from your supply store. This bracket for the face shield will come out of a 3D printer in less than 45 minutes. It's not a very, very robust design at all, but can make a world of difference for our first line responders. So once we have that real world problem that are adopted and our students are working on, where do we go next? We explore, and collaboration is key. Something that I'm going to encourage you to do, and that you're already doing, which is why you're with us today, is continue to grow in your knowledge of not only our technical tools, when we think of computer-aided design like Tinkercad, we also want to continuously, always want to continue to grow in our software and our digital teaching tools as well. That means that you have to become an expert in Zoom. Know how to use your screen share and whiteboard options. We saw me kind of finagling with that today during our webinar. We want to also, if we're using a more specialized program like AWW, ChemDraw, or LaTeX, in terms of screen share and screen annotation, we want to become experts at that. The ability to cut down the, for lack of a better word, kind of the jankiness, some of that disjointedness of what we present and the way that our students are able to share with each other, enable troubleshooting and working through with our students their own technical difficulties. That becomes really golden. The best sculptors, the best painters, the best artists in the world are in large part often the best because they don't necessarily even have the best tools, but the best understanding of how to use the tools that they have. Being an educator also means that you have a really strong command of the tools at your disposal. In that same way, you can get innovative with your tools. For our schools that are Office 365, where we can collaborate with our students together simultaneously, or if you're G Suite, if you're using Google Docs, slides, and sheets, you have the ability to do work with multiple collaborators. You can see here, there are about 6 different shades of colors inside of this Google document where one person is typing and multiple people may be typing at the same time. Connect and build on some different ways to use these tools. One little hint that I have, especially when it comes around note taking, is to create the collaborative note slide. If I've got a classroom of 24 students, I might have a Google slide that has 24 different slides on it. Assign each student their individual slide to take notes on, and students can flip back and forth between the different slides that other students are using to take notes. Note-taking and that collective knowledge becomes really, really expansive. And you as an educator are also able to be there inside that document with your students as well. So you can see if one person is taking notes, who's added what, when, whose notes are being looked at the most, whose notes might be getting copied a little bit more than somebody else's. It allows our students the opportunity to just not work in the silos, but to peak a little bit, even as they may be working in small groups or doing individualized work. It's all about collaboration and working together. especially when we think about engineering and where students are going to be working as teams. And we also want to make sure that we are really skilled at using our learning management systems. This is Canvas, Blackboard, Google Classroom, Moodle. Um, do we do a good job of setting expectations for the communications with our students over these platforms? Do they know how to send and receive messages? Do we know how to send and receive messages? Can we give clear understanding of what we're saying? Can we be disciplined and say, okay, this 45 minutes each day is the time that I have to answer messages, and our students know that. So you can build an expectation with your parents, with your students. Getting good with this tool and even building structure into it allows this to have much more success, and also builds up a really important digital skill and expectation skill for our students who may be in high school moving on to the university level. These things become paramount and become really, really useful life lessons. So hit you with a large stream of information over the last 50 or so minutes. And you guys have some really great ideas around ways to engage your students. One thing that I want to also encourage you to do is to think about the next parts of the 3D printing process, thinking about slicing, how we take that design, in my case, the keychain that we designed, and put that into software that will speak to our 3D printer. That is a skill set that gets taught to our students. Another really important skill set to think about with our students is how they actually get their physical print. If you're hybrid and you have a 3D printer in your school, great, no problem. You're there to print. Students will be in at times to print. You can practice working on the printer, but there are also services that allow you to take those 3D designs, have them printed and shipped to your students. Those are a couple of different options. Specifically, what can NextWaveSTEM do to help you? Well, the first you're already engaged in. We have been running these webinars since the last week in March, where things got really, really rough here in the Chicagoland area. And we will continue to run these webinars into the foreseeable future. We're going to see much more diverse topics. We'll be polling educators and getting a much better idea of the kind of support systems that you need. We've heard people talk about Google Classroom training. We've heard people talk about Zoom training. We've heard people get really nitty gritty with the topics they want to hear. And we're really going to have a chance to dig in and focus on more of those topics. Got a couple of good comments here. Our public libraries have 3D printers that supposedly charge a very small fee. Doreen, explore those libraries. Find out how many printers they have. Find out what that fee is. Find out if your public libraries and your schools can work hand in hand, and maybe even waive those fees for your students. I don't know if your libraries are open right now, but if they are, that may be a great time for students to spend some time social distancing. And I'm sure that if your libraries are open right now, they would love to see the traffic for students engaging in 3D printing. I got a really good question here from Christine. Do we have any services to print that you have found to be reasonably priced and reliable? The answer to that question is yes. iMaterialize is a remote printing service, and they charge a flat rate and then increases by the size and amount of material that you're printing. Check them out, and that's also actually a resource that we can link you to into the slideshow as well. Really, really good question there. So kind of back to this idea of how NextWaveSTEM can help. I love these questions. We can also really engage you and your students with our curricula. It's hands-on, or it can be completely online and remote. Our curricula are designed with those two modalities in mind, K through 12 and drones, robotics, 3D printing, and computers, and AI. Check us out at nextwavestem.com to learn more. If you go to the slideshow a little later on and you click on this button that says learn more, it'll open right up in your web browser. Oh, got another good question from Doreen. What do you think the best classroom print answer is that it's economical. Really good question. Printers are kind of like cars. They range in price. A lot of them do kind of the same thing, but it is a question of how nicely does it do that thing. You can get a really reasonable class printer for a few $100s, and there are educational printers that we see going up into the thousands. Reach out to us because we have a line on printers as well at NextWaveSTEM. That becomes really, really useful because we can get you those resources that you need. Another good question for Christine. Does Tinkercad interface look the same on iPad and as on PC? The answer is that there are slight differences because of the way the UI you move through an iPad through on a PC. On a Chromebook, on a PC, on a Mac, Tinkercad is exactly the same because it's in the browser window. But if your students have stable internet connection and have a device like an iPad or a Chromebook or a PC, they can absolutely access Tinkercad and do all of the same functionalities. Lastly, we want to make sure that we have material that works with your students really well and is adaptable. All the courses do fit remote and or hybrid models. So if you need something where you don't know what the future looks like for the winter, or we might see an unfortunate resurgence, you can rely on NextWaveSTEM courses being able to adapt as you need to adapt as well. So kind of race there towards the end because I wanted to give you a couple of minutes to ask any good questions. I already had some really good questions coming in about 3D printers, about Tinkercad. I love questions. So if you've got any other questions right now, I'm actually going to shut up for a second and let those questions come flying in. Oh, Christine, thank you so much for being with us. I'm hopeful that was helpful for you. And we definitely will want to connect some more. If you've got questions about Tinkercad on iPad, we would love to connect with you and discuss that. We are a resource for you. Are there any other questions that anyone might have? I'm taking the silence on the chat and then the Q&A is to be a good thing. I'm gonna throw a thumbs up for myself thus far. Awesome, awesome. Yes, Doreen, get that 3D printer. I know you have to do your research. We can point you in the right direction at all as well. So reach out to us and we can help you with that too. And for anyone who has any questions, my email address is really, really simple. I'm Desmond Martin, once again, Program Coordinator at NextWaveSTEM, desmond@nextwavestem.com. NextWaveSTEM is on all major social media. We are on Twitter, LinkedIn, Instagram, and Facebook. We're not on TikTok. We do neither Tik nor do we talk. There are a couple of interns that we have, so I might ask them about that. But if you see us on TikTok, or if we get on TikTok, we'll be sure to let all of you know. Once again, thank you so much for joining us today. We're hopeful that this information is helpful, that you can continue to grow in your skill set with 3D printing and with emerging technologies in general. Our next webinar is next week. I'm really excited for that. It's bringing AI learning to your students. Same bat time, same bat channel, same place. We would love to see you next week as we learn more about computers and artificial intelligence together. Until then, we're hoping that you stay safe and you have a wonderful rest of your day. Bye-bye, everyone.